All right, so last class we started topic 4 notes for sections 4.3, 4.4, 4.5 on triangle congruence theorems. And so we went over the warm-up. We noticed that we have 3 congruent angles and 3 congruent sides, and that the sides all match. Whoops. And the sides all match up in the exact locations that they're supposed to. So between the circle and the triangle here, between this circle and this triangle, I put a hashtag, and it matches number 1, and so on and so forth. When we started, we went over all 6 of our 5 congruence criterion on the board, but I also listed them here in the notes. We have side, side, side congruence, and that says that if we have 3 sides of any triangle congruent to 3 sides of any other triangle, that both triangles are congruent. That is all we need. We don't need 6 pieces of information. We simply need 3. For the second triangle congruence, we looked at the side angle side congruence. Here we see side TS and side SR are congruent to sides ZY and YX. And right between this is what we call the included angle. So we're going to label that included angle. The order matters. It goes side, angle, which means it's included between the 2 sides. So if I were to, for instance, put the mark here on Z instead of on Y, it wouldn't be correct. These wouldn't be congruent triangles because the order doesn't match. And so I'm going to erase that. We're going to erase this. We want to make sure that the angles match and that the angles on both triangles are included. And so here, it doesn't matter how you start your congruence statement. It matters how you end it. So in this case, they said that RST was congruent to XYZ. If I instead said triangle TSR, I would then say triangle ZYX. And the reason is that I'm going in order. So I started at T, and I went down the side that had 1 tick mark, and I wrapped around this intersection of this included side at this vertice, and now I'm coming down the second one. So TSR would be ZYX. So the order needs to match, and really this matters the most, that this is included between the 2 sides. For angle side angle, we have a side included. So the side is included. And here we see that included side, MN and ST. So here, the angles are the ones that are on the outskirts, and in between is the included sides. So this side MN matches with side ST. You have 1 tick mark and 2 tick marks. So MLN is congruent to SRT. I could have even said something like triangle NML is congruent to triangle. So if I go NML, what I've done is I've started at N, which is 2 tick marks. I've gone down the side, that's 1 tick mark. And then I've turned at the 1 tick mark angle. So here I would start at T, I would go towards S, and end at R. So triangle TSR. Again, it doesn't matter how you start your triangle congruence statement, it just matters how you end it. For angle side, you notice that you have to hop over a side. So it goes angle, hop, angle side. So there is nothing included. There is no inclusion for this one. There is no inclusion. Notice that the inclusion is missing. So we go angle, no inclusion, angle side. So that's our order there. And then this goes angle, no inclusion, angle side. That's probably the toughest one to see because they're not pinned together. This UV is being skipped over, and this XY is being skipped over. Notice the markings match. 1, 2, 1, 1, 2, 1. And that was, let's see, we did side, 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 angle, side, angle, side, angle, 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 side. And then when we were talked about SSA, we said we can't do SSA. SSA doesn't work because it has what we call an ambiguous case. But SSA can work as long as I have a hypotenuse, a leg, and a right angle. We have a hypotenuse, a leg, and a right angle. So in this case, my hypotenuse is always opposite my right angle. So I have both a right angle and a hypotenuse. Here I have a right angle and I have a hypotenuse. And it really doesn't matter which leg you use as long as you use one of the sets. In this case, they have ML, this is my leg right here, ML, and RP. They could have also used NL or NRQ, but no matter what, you have to use the hypotenuse. So here, we did the hypotenuse, that was good. We did a right angle, that was good, and a leg. Just because you see a right angle does not mean that you immediately default to HL theorem. I think at the end of this, I think I listed some versions of it. So here is where you actually have side, angle, side with a right angle. Here's where you have angle, side, angle with a right angle. Here we have angle, angle, side, where only one side is being used and two angles are being used. Where we have a skipped over or hopped over side, HI and KL. And then this last one is the hypotenuse leg, because we do have a hypotenuse, we do have a leg, and we do have a right angle. So if you're tempted to write SSA, make sure that it doesn't work only when, it doesn't work unless you have a hypotenuse, a leg, and a right angle. And that's my check. So now we're just going to go through and do different examples. We started with this one. We said this one was congruent, that these two triangles are congruent by side, side, side. The one below it, we said SSA, and because we don't know enough about it, we don't know if that's a right angle. It appears not to be a right angle. This one, we can't make any other assumptions, so this one will not work, the SSA one that we drew out in purple. Over here, we said that one's totally cool because side, angle, side, congruence criterion. And I'll label that side, angle, side, and side, angle, side. For this one, SAS and SAS worked. Notice that your angle is included. And the next one says, what additional information is needed to prove these two triangles congruent by side, angle, side? So for this, I start with my side, I start with my angle, I start with my side, I continue on to my angle, and this is the side that's missing. Here I have side, and I have angle, and this side is missing. So the answer to this would be, we would need to know that side AC would be congruent to side, I said AC, so I would have to say DF. So our missing piece of information is DF would have to be congruent to AC, or vice versa. So that is what we would need to know. I am not stating that they are congruent. I am simply stating that information is needed That is what is needed to know that they are congruent by side, angle, side. And it tells us exactly what we wanted. They didn't say angle, side, angle. If they said angle, side, angle, I'd be dealing with angle B and angle E. So it will tell us right in the diagram, right in the sentence, in our question, what missing piece of information would you need to know to make that work out. Right now, we all agree, or would hopefully we all agree that these are not congruent yet because we don't have that third piece of information that we need. In the next example, is this one congruent? We have a side, an angle, and a side. We have a side, an angle, and a side. It goes in the correct order. The angle is included. So we would say yes, triangle STU. STU is congruent to triangle XYZ, sorry, by the side, angle, side congruence criterion. You're just making sure the order matters. We have two sides and an angle, right? That could only be this one or the hypotenuse-like theorem, but there are no right angles. We're not dealing with hypotenuses. We are simply using the side, angle, side. All right. Is any additional information needed to show that DEF is congruent to GHJ by side, angle, side? In this one, side, angle, side, side, angle, side, side, angle, side. They chose, unfortunately, they chose the wrong sides. This side, this does not help us. This side does not help us. Or these sides. I'm going to change it to these sides. These sides do not help us. So the answer is yes. We would need to know that side ED is congruent, and I want to make sure I go in the right order, so HG. To prove that triangle DEF is congruent to triangle GHJ by side, angle, side. In the next example, it asks us a whole bunch of questions about whether or not these are congruent. And what we notice is that JKL is nicely positioned with a side, an angle, and a side, where side JK is included between the two angles. So this is leading me to believe we need to work with side, angle, side. Oh, sorry, I labeled these backwards. Angle, side, angle. My apologies. Angle, side, angle. And the next one, where the sides included JK, my apologies. M is angle, side, angle. MNO is angle, side, angle again. So it looks like ASA, ASA. The problem with this one is this one goes angle, angle, side. So we can't mix and match which ones we want to use. We can't use side, angle, side with angle, angle, side. So it's either one or the other. So in this case, JKL, MNO, we're going to say yes. Yes, triangle JKL is congruent to triangle MNO by angle, side, angle congruence criterion. However, triangle JKL is not congruent to triangle PQR because one triangle, let's say because triangle JKL is using ASA congruence criterion, while triangle PQR is using AAS congruence criterion. All right, so using triangle congruence criterion, state whether each pair of triangles is congruent by side angle side, side side side, angle, or angle side, or if it cannot be determined. So in the first one, we have angle side angle and angle side angle. So it's yes by angle side angle congruence criterion. In an effort to save time, I'm not going to keep writing the words congruence criterion. I'll just write the abbreviation. And this next one, it's looking pretty good with side, side, side. So we'll say yes, side, side, side. In the next one, we have angle, side. I'm skipping over. I skipped over this one. And I started at the 2 tick marks, so I'll go in the same direction. Angle, side, where I skipped over that side. It's not included, so angle, side, and angle, side works. Great. So yes, angle, side. And for the last one, I think there's definitely a problem with this one. We have a side, angle, side congruence, where I started at the 1 tick mark, and as I wrapped around, I did side, angle, side. But the problem with this one is it's SSA in the wrong order, so we're going to say no, not enough info. We're not saying that they are not congruent. We are saying we don't have enough information to determine their congruence. Just because they're marked partially doesn't mean that there's not more going on with it, but we simply don't know enough based on how it's marked.
Would that come up on like the test?
Yeah, so it's going to be, that's a great question. It could come up on the test. The goal here is to try to trick you, right? Because you got to be focusing in on order. You just start somewhere and you wrap around. Obviously, I can't start here because there's no tick mark. I can't start here because there's no tick mark. So I have to start at one of these tick marks and go around. So here I did SSA. Here I started the 1 tick mark, did SSS. Notice that none of the angles are included, right? We're not dealing with angles and sides. So if we're not doing that, we are just going around without inclusion for these. All right. What additional information is needed to show? Again, we don't know that they're congruent. We're simply looking at how they want us to do the congruence. They want ASA. So they want ASA. So in this case, I'm going to start here at an angle, a side, and then an angle. So angle, side, and angle. So we would need to know that angle B was congruent to angle E. How would we know by angle, side? That's where we're going to have to skip. So I can't use angle B. Instead, I'll use angle C and F. Because for this one, it would go angle, side, and angle, side, side, where this is the skipped side with no inclusion, and this is the skipped side with no inclusion. So angle F and angle C is what I'd be looking at. If I asked you multiple questions on this, you would, I think, erasing what you already had, what I wrote in red or maroon, you could erase that, and then you could approach it again. But angle, side, so it would be angle C would have to be congruent, and I forgot, it was angle C and angle F. That's the only way to do it by angle, side. And then I think we're almost done. Ashton is washing windows using a 10-foot ladder. For the first window, the ladder reaches the window when he places the base of the ladder at the rose bush. How can he determine where to place the ladder to be sure it reaches the last window? And so for it to reach the last window, we would have to put it in line with the rose bush, right? We would have to run this line and continue that line along the side of the rose bush. What we're dealing with here is what appears to be a right triangle. We have a right triangle down here, right angle, and we have a 10-foot ladder. We want to create a visual of another 10-foot ladder with the same right angle, because it is going to be, the ladder itself will not change in length, which means that I want this measurement on the ground to be equivalent to this measurement on the ground, which means that we are using the hypotenuse. We have a hypotenuse that's congruent to the other hypotenuse. We have a leg congruent to another leg, and we have a right angle, meaning that we can use the HL theorem, the hypotenuse leg theorem, to make this work. So for our last question of the lesson, it says, what information is needed in order to apply the hypotenuse leg theorem? In this case, we know that the hypotenuse for Ln is 9. So we would have to know that PR would be 9. We don't know that, but we're going to say that we would need to know that PR is equal to 9 units. We would also need to know that either QR, we would either need to know that ML is equal to 5 or MN is equal to 5. Visually, MN looks like the side we'd be working with. It does look like the shorter side, and it looks like it matches QR. But again, in geometry, we can't make those assumptions visually like that. So what we are going to do is say that either side ML or either side ML or MN will have to be 5. That would give us the congruent leg, the congruent hypotenuse that we're looking for, and then my right angles that are there. All right. Again, we already covered this, that right angles don't immediately draw you to HL. They could, but they could be also side, angle, or angle, side. You just have to know, are we dealing with a particular order, or are we looking at the hypotenuse and leg? And at this time, you can begin your practice. It's thorough. It's on 4-3, some questions on 4-4, and then other questions on 4-5.